Gear Tasting Radio is brought to you by Imminent Threat Solutions. ITS provides knowledge that empowers individuals with indispensable skill sets to explore the world and prevail against all threats. Right now, as a special thank you for all podcast listeners, we're offering 10% off in the ITS store. Simply use the code GTR to save 10% at store.itstactical.com. Welcome to Gear Tasting Radio, where we offer an in-depth look into the usage and philosophy behind the equipment in our lives. I am joined by Rob Henderson.
Hello.
And I'm Brian Black. Today we are talking rope. So very interesting stuff. However, I think there's some cool merit in discussing different types of rope and what they're used for, because I feel like there are misnomers out there in terms of what kind of rope should I use for what, and what does kermantle mean, and all the things that kind of go into a rope selection if you're tying knots or even lashing something down. So we talk a lot about knots on our Knot of the Week series and how to tie them, but in terms of selecting rope, maybe that's not always as black and white as people might think.
Yeah.
So I like to break rope down into a couple of different categories. First of all, there's synthetic and natural fiber. I think that's kind of the first genre, if you will, of rope construction. So synthetic would mean any kind of polyester or non-man-made product. So natural fiber is stuff like jute and hemp and I guess sisal. I don't know, sisal.
So
I don't know
natural fiber is not man-made?
Correct.
Okay.
Yeah, and that's what I mean by that is that you've got it's a fibrous rope. I mean, I don't really know how else to describe that other than
itchy.
Yeah, you could call it that. One characteristic of it, if I could describe it, it's that it does not, you can't fuse it like you can with synthetic rope. So synthetic rope, you can take a lighter to it and actually fuse it and close off that cut. Whereas synthetic or natural fiber rope, you can't do that. You have to either back splice it or close it off somehow with a knot so that it stops unraveling.
And is that because when you're doing a synthetic rope, you're actually melting?
Correct.
The material? Okay, so basically this natural fiber doesn't melt.
Yeah, it doesn't melt, but it does burn, so to speak.
But so the fusing that I'm used to with like paracord, rounding it off and stuff, comes from the melting of the line. And with this, because I've tried that before without thinking about it, and you're like, I can't do this.
Yeah, and that's really the litmus test for natural fiber versus synthetic is does it blend?
Try to set it on fire.
Yeah, right. A funny story, and I think I've told this elsewhere at one time, but I was getting some rope for a project we were doing at ITS, and I was there with my buddy Jack from Survival Podcast, and we were relaying to the guy at Home Depot that we needed so many feet of this jute rope that I needed, and he proceeded to measure out the rope and then take it and try to cut it on the burning device. It's basically like a hot knife that they have set up there for cutting rope, and he was taking this natural fiber rope and attempting to saw it back and forth on the hot knife to cut it. And he, I have a video of it.
That's what he learned in the online learning.
It was so hilarious. I just started to film him, and I don't typically do that, but I was just, I couldn't contain myself. But he was funny. Just, because it was catching on fire.
Because it's like smoking.
Yeah. And it was just, it was smoking. But anyway, another natural fiber example is like a cotton rope. We've been using cotton rope in a lot of our DIY knot tying videos lately because we're building a knot board, basically. So we're taking a bunch of knots and displaying them on a board, and we're using this cotton rope because of its characteristics for absorbing materials like glue so that it kind of like stays true to form. So we're kind of doing that there. But a couple other types of synthetics would be like a kermantle rope, like a climbing rope, and we can get into that. Accessory cord is typically always a synthetic. You've got just regular nylon braided rope as well, and then paracord is a synthetic as well. So from there, you have the difference between synthetic and natural fiber. I think the biggest breakdown from the synthetic category would be really just kermantle versus non-kermantle first. And Kermanel construction, it's a German word, so...
I was going to say, it sounds real fancy.
Yeah, so, I mean, Kern comes from the word core, and then mantle is like the cover or sheath. So that's where the word Kermanel comes from.
So basically it means it has an inner strand?
Yeah.
Okay.
And the characteristics of Kermanel are, like a nylon or synthetic braided, multi-braided line inside of the polyester or nylon wrapped core. And this is, typically it's done on a loom, so you've got kind of a twisted pair type. I mean, twisted pair is really more of a computer cable type terminology, but I like saying that, even though it's really kind of like 3 pieces of fibrous nylon twisted together. So, it has a natural twist to it. But ropes like this, you can't splice, whereas a natural fiber, it's got the actual strands. So this natural fiber, for instance, that I'm holding is like a sisal rope, and it's got kind of a natural twist to it because it basically held the shape whenever the machine twisted it that way. So what you can do is you can unwrap those strands and you can splice them together in a specific way so that the rope can join each other, and you can join ropes with splicing with natural fiber, and you can't do that with Kermanel ropes. You have to use a knot.
I'm just realizing I've never thought about the fact that most of the synthetic that I have seen does have inner strands versus like natural. I've never seen that. So yeah, that makes a lot of sense.
Yeah. And the great thing about synthetic though is that it's typically higher weight rated, so you can do things like climb with it depending on the type of rope you're using. And even kind of tubular webbing is a synthetic as well, and we can talk about that a little bit too, because that's used extensively in climbing, and that's really how I separate rope too. I mean, even though there's Kermanel and non-Kermanel construction, there's also, in my opinion, climbing versus general purpose rope too. Like there's a lot of Kermanel construction rope that I would not climb with. I mean, there's just there's a safety implication of that, not only weight rating, but you're talking about ropes that are designed for climbing and designed for weight bearing, whether they're a static or dynamic, which we'll get into in a little bit. But I also feel that that's another way to distinguish them as well.
So just because it's synthetic and Kermanel does not mean it's climbing capable.
Yep. Okay. Very true.
It's like we're doing like a flow chart. It's like flowing down more and more.
I know this is kind of a lot of information, but this is just kind of my brainstorming as well as we're talking. But, I mean, even paracord is a Kermanel construction. So, and I'm not going to trust my life to a piece of paracord, whereas some people are like, well, I weigh 180 pounds, and this is 550-pound test, so, that's not the way it works. Because when you're falling in that situation, you're... I don't know, the scientific calculation for the force that's exerted on a line is way more than 550 pounds.
Yeah, I was going to say, like your body weight isn't the inertia that you have when you hit the end of that line.
Yeah.
You're a lot heavier.
Yeah, and fall factor involves a lot of different things. There's definitely calculations you can look up, but it has to do with the height that the fall takes place in, as well as the length of the line that is available to absorb the fall too. So there's, in climbing, if you have a hard fall, and the definition of a hard fall is like, 10 to 15 meters and a fall factor that's greater than 1. So in the formula, which is a fall factor formula, it's like F equals H over L. So like height of the fall over the length of the line. You can actually do the math on that and figure out whether that was a fall factor of 1 or greater.
Gotcha. Okay.
So anything greater than a 1, or typically rule of thumb 10 to 15 meters, you should retire that rope. So yeah, if you're in a climbing situation and that happens to your rope, I would definitely stop using the rope. And that's not always the case in a lot of times when people are climbing, because they'll sustain fall after fall while doing lead climbing because they don't really have a choice. They're, the ropes are the ropes, and they only brought so many. Brought so many.
Get rid of it.
Yeah. So with Kermanel, static versus dynamic, means that the rope was engineered in a way that it has give to it or stretch that's built in, whereas static rope is used more for general utility purposes or rappelling. So you don't really want to you don't want to rappel with a dynamic rope. You want to rappel with a static rope. And that's not to say you're not going to sustain a fall with a static rope, but you're less likely to do that in a rappelling situation because you have complete control over your belay or your belay device or your air traffic control device, ATC, what have you, whatever you're belaying or whatever you're climbing with, whether it's a figure eight or what, but rappelling with is what I should say. But if you're doing something like a top roping or lead climbing, you're going to want to use a dynamic rope because it's going to be able to absorb the impact of your fall if that happens.
And so that's why, like, sometimes I've seen rappellers, you know, you fall 5 feet or whatever, there's a little bounce, and that's from the dynamic. Well, I guess that's displacing the weight.
You might have seen that in top roping, but typically any time that I'm doing rappelling, I'm using a static line.
Oh, okay.
Yeah, I don't usually use, or I don't use at all. I don't use a dynamic line whenever I'm doing rappelling stuff. Just because you want the rigidity and the non-give to a rope. Because especially if you're, you know, kind of lowering yourself over the side of a ledge as you're doing that, you kind of, there becomes a point in your traverse over the edge that you kind of have to allow the rope to catch you, and you really don't want
any give.
You don't want that give from the dynamic in that situation. You could use it. I mean, there's nothing technically wrong with it, but I mean, if you have a choice, I would highly recommend static rope over dynamic. And personally, I like blue water static rope. It's kind of like an industry standard, if you will, for things like rappelling. So. That's typically like, I believe, 11.4 millimeters or something like that. 11.4 is the thickness of the rope. I have it written down here. Okay. Hold on. 11.4 millimeters. Yeah. So
is that's a minimum requirement, or is that just the target?
That's the actual thickness of the static line. So it's an 11.4 millimeter line, and you know that's rated too. So there's a body that out there that tests rope, and I would only buy something that's rated for climbing. You know, you'll typically be able to read that on any kind of rope you're buying, whether or not there's an actual rating on it. So highly encourage that. Let me think of what else. Oh, I didn't talk about accessory cord. Accessory cord is really kind of Kermanel as well. But it's a smaller diameter, whereas, you know, that blue water static line I talked about is like 11.4 millimeters. You're talking about like a 6 millimeter line or 5 millimeter line or something like that. And I want to say this is a blue water accessory cord that I'm kind of messing with right here. And this is what I use for Prusik loops. So when I'm rappelling, I will back up a rappel with a Prusik loop so that it will catch me in case I fall that way too. And I mean, really, ideally, I would have a belayer, like a top belay, if I was doing rappelling work. I really wouldn't want to trust anything to a Prusik, but if you're, you know, operating by yourself and you're having to rappel down something and there's no other choice, you would definitely want to tie off a Prusik so that you at least had a backup for that.
And so what's the benefit in tying a Prusik with the accessory instead of the actual like line that you were using? So
well, you would have to cut off some of the line, and you don't want to ever do that to your climbing rope.
Oh, okay.
You want to keep your climbing rope as intact and damage-free as possible. So you never want to start splicing or cutting off pieces of your rope.
Well, I didn't know if you could buy
like that,
like the same length in that blue water.
So the way that the accessory cord works is that because it's a smaller diameter than the rope itself that you're climbing with, it's going to bite better into the rope.
I got you. All right.
And that's a characteristic we really didn't talk about, and we can kind of rehash with natural fiber too. There's a reason you use that when you're lashing things together, especially like natural pieces of wood and things like that, because the fibrous nature of the natural fiber is going to bite into that a lot better. So
that's that itchy factor.
Yeah,
because it does have like a very tacky feel.
Yeah, and that will really grip when you're tying something like when you're doing making like lashing together a structure or something like that. So
gotcha.
But yeah, the benefit of a Prusik is that you basically tie it with a double fisherman's knot, and you create a loop, and then you wrap that loop a specific way around the rope, and that's actually what catches you. It's kind of like a friction hitch,
so
if
it binds to the rope
so
as you
it
fall.
binds.
Okay.
And that's attached to your harness, so that if you let go of the rope as you're rappelling, at least you've got that Prusik there that binds. Yeah.
That's awesome.
But the problem, then again, lies in the fact that Prusiks are really hard to get out of a rope. So you really have to have a way to almost attach another Prusik to the line to alleviate the weight from the rope to be able to untie the Prusik to maybe get down the line. So there's safety precautions you want to take when you're using a Prusik too, because if it does bind up, you may need someone to come over the edge and get you unstuck. Or you may need to be able to
locks you up.
Yeah, you might be able to need to self-rescue yourself, so to speak, in that situation too, where you've got another Prusik tied higher, and you have a longer line that you step into, almost like a stirrup, and then you alleviate the weight on the line so that you can undo the Prusik.
Because your
that
body
makes
weight
sense,
is what's
right?
Okay,
Correct.
I got you.
Yeah, because it's holding on. Yeah, but yeah, that's kind of went off on a tangent a little bit, but when you're talking about kind of the everyday nylon braided line, this is kind of the most common thing that people find in the hardware store.
Yeah.
And there's nothing wrong with tying knots in this if you're tying down a tarp or something like that in the back of a truck, but you definitely don't want to trust this in applications where a life-saving application for sure. But there's certainly nothing wrong with using this. I don't really like this kind of rope. If I had, my choice, I would opt for something like a Kermantle accessory line rather than something like a.
I was going to say, if I could only pick one rope, you might as well get a rope that can do more.
Yeah.
Than just.
Be
good for
one of the issues though lies in the fact that ropes do wear out. Over time, as abrasion happens and ropes rub back against even the truck bed or something like that, the Kermantle. Let's just take a Kermantle rope, for example. The sheath of that will start to degrade and pill up and things like that. So you always want to check your ropes, especially in a life-saving situation or something where you're trusting your life to the rope. You always want to make sure you're checking the rope first before you climb with it or rappel with it. So,
and is that just running it through? Yeah,
and that just means passing it through your hand and looking for any major abrasions or damage to the rope. You also want to semi-regularly clean your rope too, and that literally can be done in a washing machine. There's commercially available things to actually wash a rope out there, like devices. But you can just chain sennit a rope, throw it in the washing machine, and as long as you're not using harsh detergent, you can even just run water through the washing machine and not use detergent at all, and it'll clean it up.
I had never thought about that.
Yeah,
That's
I don't
cool.
really do that very often. It's only if a rope is super dirty will I do something like that. But, a sign of or a damage on a rope is a sign that you need to retire the rope too. So always check that kind of thing too. But yeah, if you're working with something like a rope in the back of a truck, there's nothing wrong with a braided nylon line. It's cheap, it's inexpensive, and as long as you're checking it before you're trusting your tied down bookshelf to it.
Yeah.
Make sure that you're checking for it. And that's where knots really come in handy too, is that most people use knots in the situation where they're tying something down. That's the average use for a knot. Unless you're climbing or something like that, then you have kind of your go-to knots for that too. I'm really a big fan of tubular webbing. Tubular webbing is something that's very heavily used in the climbing world for anchors and things like that, but it's some of the strongest stuff out there. I think in terms of the weight rating of tubular webbing, I don't want to mess it up, so I have it written down. So it's got a rating of like 17.8 kilonewtons, and this is like the good stuff. This is not just ordering tubular webbing on Amazon. This is like going to a climbing store and making sure you're buying good tubular webbing. Like Blue Water is a name brand that makes tubular webbing. But 17.8 kilonewtons is equal to about 4,000 pounds of force. So this can really take
that's
a beating.
nuts.
Yeah. So, and then, we can kind of get into the climbing math stuff too, which is that anytime you tie a knot in a line, whether it's tubular webbing or a piece of rope, you're actually reducing the rating of that rope depending on what kind of knot you use too.
So just by tying a knot?
Yeah, just by tying a knot, you're reducing the overall nature of how strong that rope is. For instance, one of the least friendly knots to rope weight
don't
rating
tie this one
is a square knot. I mean, that reduces the strength of a rope by 50%.
Whoa,
I believe
that's a lot.
Yeah, it's a lot. Whereas something like a figure eight, I think, is like 70 to 75%. So meaning you've got a 25 to 30% reduction in the strength of the rope if you're tying a figure eight. So that's why things like figure eights and double fishermen's and things are really popular in climbing, because those knots are some of the least reduction in weight.
I wonder if it's because it spreads the knot out. Like a figure eight, I'm thinking in my head, is a bit longer of a knot, I guess, than a square knot, and a square knot is just real small. That's interesting.
Yeah, I mean, I think it also has to do with the bends as well.
That you're causing the rope to go through because you're already putting it under strain.
Yeah. But yeah, I don't really know the specific answer for that.
That's cool.
I mean, I'd be interested to know now that we're talking about it. But so like rope in itself, you can think of just a line. You've got 100% of the rating there. But the minute you kink it or twist it or tie it, you're really reducing the amount of strength on that too. And I think it really has to do with anytime you introduce a knot, you've got a point now in the line that I guess the rope is going to pull on. If you fell on that line, that knot is going to catch. It's going to bind or absorb the weight of the fall. Right. Right on.
Well, because that's what I was just thinking. Is like, let's say you tied it around a tree at the top, but then as you come down, if you have a knot, that's kind of like your new top point almost. Yeah. I mean, you still have the remainder, but I could see why that would be such a detriment to have such a shock hit something like that.
Yeah, so like some other ones I have written down that come from the climbing math video I did a long time ago, or so figure eight, 70-75%, double bow line, 70-75%, double fisherman, 65 to 70. And what I'm saying about this is you have to think of what's left as the reduction in strength. So it's not reducing. Yeah, it's not reducing it by 75%. You're really reducing it by 25 to 30%, right? So tape knot is 60 to 70%, and that's also known as a water knot. That's commonly tied in tubular webbing. Then just a simple overhand knot is 60 to 65%. Clove hitch is 60 to 65%, and square knot is actually 45, not 50.
Wow, so you're losing 55% of the capacity. Wow.
Yeah. So
don't tie a square knot.
Yeah, exactly. And then tubular webbing is interesting too, because as you start to double this and work with it, you can actually increase the weight rating of tubular webbing depending on how you're utilizing it. So let's say you had a continuous loop of tubular webbing. You've got that, 17.8 kilonewtons of force. There's always going to be a point at which you've got to connect tubular webbing. You can't just make a concentric circle of it. So, anytime possible. You do that, no matter what it is, you're really kind of, you can use 17.8 as a baseline, but just for kind of climbing math purposes, let's just say 24 because it's an easily divisible number.
Right.
So you've got your single loop, which is 24. If you put if you girth hitch this around a line, now you would reduce that in half to 12 kilonewtons.
Okay, so that's the knot aspect.
Correct. Okay. Now, if you were to take a continuous loop and actually fold that over a line so that you had two points of contact with it, I kind of view that as like a double pass, if you will. So you're basically creating two loops over a line, and let's say you connect a carabiner to it. You've now actually doubled the strength of that line. So now you're at 48 kilonewtons.
And you're accomplishing the same thing a girth hitch would.
Almost.
Pretty much, yeah.
Yeah.
Oh, that's interesting.
And then if you actually tripled it, you had three loops, that come down, and I'd have to have a longer piece to demonstrate that. But then you got 96 now, so you can actually increase the rating of a piece of tubular webbing. I mean, this goes for rope too. It just depends on how you have to account for the knot. You always have to do that too. So you think about the weight rating reduction first of the knot you're using to make the concentric loop, and then as you start to do that, that's just kind of the nature of
cool.
climbing math. Yeah, it's kind of cool.
Yeah,
but that's just kind of some off the wall stuff that most people don't think about when you're talking about ropes, and it's something I geek out on. I'm pretty interested in it, and
because I had one thing in my mind for rope. When I think of rope, I think of like Clue. Like the rope
with the candlestick.
Right. Yeah. So this is interesting because it is, and I've never thought about it. And I've used all this stuff before, but never really dug into the science behind it.
Yeah, I mean, to jump back to kind of like what we were talking about for the average person tying stuff down, I think tubular webbing is some of the best stuff too. Like I would keep that in the back of a truck to tie stuff down with over rope, just because I feel like it's got a stronger weight rating, and I would trust it more.
Yeah,
when it comes to things like that too. And you can easily join two pieces of tubular webbing together with a tape knot or a water knot too.
Yeah,
it's just kind of tracing it through. And we'll link to some stuff in the episode intel that
we'll put that video in, and
talks about the climbing math demystified and all that good stuff about rope, all the stuff that you didn't even think about, and now hopefully you're interested.
Yeah, now you want to know more.
Yeah. So that's our gear tasting episode on rope. All right, thanks for listening to Gear Tasting Radio. Remember, if you have questions, and hey, if you have questions over rope and you want to know more about a specific thing, even more of the climbing math stuff, shoot us a pound tag on any social media network using the pound tag Gear Tasting, and we will find your question and get them answered for you. Love questions about this kind of stuff, especially the kind of stuff that I geek out on. It's always fun to entertain those things, and if it's a quick answer, sometimes I'll just hit you back on social media too, from our ITS accounts. But anyway, if you're interested in kind of helping to support the show, which we hope you are, we've got a crew leader membership. That's our way of kind of giving you back something for your support through our membership. And then even if the membership isn't for you and you want to help us out, please consider subscribing on Apple Podcasts. We would love your review. Reviews help the show grow, and they'll also allow Apple Podcasts or iTunes, wherever they call themselves these days, to help kind of spread the love on our show and get more people interested in it. So very much appreciate it. Thanks for listening, and we'll see you next time.